Hey everybody, this is section 5 and this is all about angle of elevation and angle of depression. We're going to be still using our trig functions, so just a reminder, you're still going to be using SOHCAHTOA, but we're going to be talking about how we can find different measurements, whether it's an angle measure or a height, if you're given word problems that require elevation, angle of elevation, angle of depression. Okay, so right here in this box we've got what our angle of elevation and angle of depression look like. So I've got a house here and then the Eiffel Tower, and angle of elevation is usually on the bottom. So this is going to be where if I've got my horizontal line on the bottom, so that would be like the ground, angle of elevation would be from the ground looking up. Okay, so this is my angle of elevation. My line of sight is always my hypotenuse. Okay, so usually if it's like a person's looking at the line of sight, it's going to go up to something or down to something. And then angle of depression is the one that people tend to get confused with, because it's not just this top angle. Angle of elevation and angle of depression are always from a horizontal. So you draw a dotted line straight across and then you go down. And what you should notice, and I put this little note here in yellow, the top horizontal and the bottom horizontal are both parallel to each other. So because we have two parallel lines, so here I'll draw this, two parallel lines, notice that my line of sight is kind of like my transversal. So what this means is that I have two angles that should be congruent. So the angle of elevation should be congruent to the angle of depression. Okay, I'm just abbreviating. So always important, those should be the same. But angle of depression will never be inside the triangle. In most cases, it's going to be on the outside. So we're just going to jump into some basic examples here. So let's look at number 1. It says the angle of elevation from point A to the top of a press box is 49 degrees. So let's think of our press box being up here. So here's our press box, and it tells us that point A is somewhere over here. And it says the angle of elevation is 49 degrees. So here's our horizontal on the bottom. So our angle of elevation is going to go straight diagonally from there. So angle of elevation is going to be 49 degrees. And it says if point A is 400 feet from the base of the press box. So here's the base of the press box. So that means this is 400 feet. How high is the press box? So what are we looking for? X right there. So now this requires us to use a sine, cosine, or tangent function. So if we look at from our angle, we have this is opposite, and then 400 feet is adjacent. So opposite over adjacent, that's our tangent function. So we have the tangent of our angle equals the opposite over the adjacent. And then of course we can just use our calculators to start to solve. So we would multiply both sides by 400. So these cancel, and then you would type in your calculator 400 times the tangent of 49. Make sure your calculator's in degrees, and you get that x is equal to 460.1 feet. Okay, and don't forget units if we have them. So there's our height. So it's very similar to the right triangle trig that you just did in the last section, but this time you're going to see different wording. It's going to be lots of word problems, and you're going to deal with more angles in this case. So let's try number 2. It says find the angle of elevation of the sun when a 12.5 foot post casts an 18-foot shadow. So if we draw the sun, okay, lovely. I'll even put a smiley face on it. And it says that we've got an 18-foot post. Okay, so here's our post. Or sorry, 12.5-foot post with an 18-foot shadow. Just a side note, shadows are always going to be on the ground. So here's our 18-foot shadow, and then here is our 12.5-foot post, and they want to know what the angle of elevation is. So that would look like from where the shadow hits up to the sun. So that's going to be right here. So we don't know the angle of elevation. So now we have opposite over adjacent. That's another tangent function. So tangent of our x value, we don't know that. Okay, I'll call that x equals opposite over adjacent. And remember from the last section, if you can't find the angle, if you don't have it, this is where you do inverse. So you hit second tangent, so it's got the little -1, and then you type in your fraction. So 12.5 divided by 18, and you close your parentheses. So when you do that, divided by 18, you get 34.8 degrees. so 34.8 degrees, and you'd be done. And it'll tell you what to round to. Usually we'll do nearest tenth, but if it says otherwise, please make sure you be careful what you round to. So I want you guys to go ahead and try number 3 and number 4, or actually just do number 3, and then check your answer here in a second, and then we will go through number 4. Alright, so there's a ladder leaning up against a barn. So if we have a barn here, okay, it doesn't really matter what it looks like, excuse my drawing, and we've got a ladder leaning up against the barn. Okay, so here's our ladder, and it says that they know the angle is 78 degrees, okay, and the ladder is 5 feet from the barn, and they want to know how long is the ladder. Well, in this case, that's our line of sight. We don't know how long the ladder is. We don't care about the height of the building, okay, we just want to know what the ladder length is. So looking from this angle, we know we have an adjacent, and we know we have a hypotenuse. So if you think of SOHCAHTOA, adjacent over hypotenuse, that's cosine. So we have the cosine of our angle, which was 78 degrees, equals our adjacent over our hypotenuse. Remember the trick? If x is on the bottom, we can just switch these two things. So we get x equals 5 divided by the cosine of 78. Please make sure you use parentheses, okay? Because otherwise it will get really confused in your calculator, but you should get that the ladder is going to be 24 feet, roughly. Okay. Now, looking at number 4, we're dealing with an angle of elevation, or angle of depression problem. So it says from the top of a 120-foot fire tower, okay, so here's our fire tower, a ranger observes a fire at an angle of depression of 19 degrees. Remember, angle of depression is from a horizontal. So if we go down from that horizontal line 19 degrees, that's our angle of depression. So then he looked down all the way over here, and there was some fire. Okay, so fire. Okay, so there's our angle of depression, and it says how far away from the base of the tower is the fire. So it wants to know, okay, how far is this? So how far is it? X, and we know that the tower is 120 feet. So label what you can. Well, right now we don't have enough inside the triangle, but remember the angle of elevation and depression are exactly the same. So if this right here is 19 degrees, go to your alternate interior angle. That means that has to be 19 degrees. Okay, so it's going to be very helpful. So now we have an opposite and adjacent, so that's our tangent function. So the tangent of our angle equals our opposite over adjacent. We can switch the bottom and the tangent, so x equals 120 divided by tangent of 19, and of course you can type that in your calculator. So let's see, so we would get 348.5 feet in this case. So the fire is 348.5 feet away, and then you would be done. So if you're given depression, angle of depression, more likely than not you're going to have to replace it and put it in the angle of elevation spot so that you can use sine, cosine, or tangent.